all, is it growth or decay? Growth. How do you know? Oh, okay, I heard bigger than 1. I also heard that it's going up. Yay, good. For domain, what's the domain of all exponential functions? Oh, wow. Negative infinity to positive infinity. Remember, you always tell me left to right. Left to right. Okay. Now, is there an asymptote on this guy? Yes. What is it? -3. There you go. All right. And a lot of y'all seem like you were kind of questioning it. Remember, you can look at the equation and its number chilling out here. So we got y equals -3. What's up? No. All right. For range, what's our range going to be? What's our lowest y value? -3. Okay. And then what's our highest y value? Infinity. Because there's a horizontal asymptote. All right, good talk. Okay. So as x is approaching positive infinity, so as we're moving to the right, so if we were standing right here, as we move to the right, where are our y values going? Up. As we move to the left, where are our y values going? To where? To -3.
I have a question.
What?
So when you
All right. What's up?
like the growth is like greater than 1, what do you mean greater than 1? Like where's
The b value?
oh, okay.
Yeah, this guy. Good question though. All right. So are there any x-intercepts here? Does it cross the x-axis at all? Where is it at? Like 1.5-ish. Okay, we're gonna say 1.5. That might be a little off. Little. Okay. All right. What about y-intercepts? Does it cross the y-axis? Does it cross the y-axis? Yeah, at -2. Is it increasing or is it decreasing? It's increasing, right? Yeah. Okay, and it's increasing the entire time. Is it ever decreasing? No, we're gonna put NA or not available. Just each statement. Which do you think matches each statement? I have a y-intercept of 100. Which one has a y-intercept of 100? The table. Okay. I have an asymptote of y equals 0. The graph. Okay. I have a domain of x is greater than or equal to 0. The graph and the table, both. Great question. Okay, take a moment, kind of make this sketch, kind of make this table, maybe write those down. So I'm going to read it to you because I'm awesome at reading, right? The amount accumulated in a bank account over a time period, T, is found using this formula, where T is greater than or equal to 0, and A of T reflects the total in dollars. Yeah, I've got issues, it's fine. The graph is shown above. 4 students are analyzing the graph. This is what they each say. Rebecca says this graph starts at 0, 200. That means the bank account started with nothing and now has more than 30. Is that true? No, Rebecca, you're wrong. Do better. Okay. What about Bridget? This bank account keeps changing by a constant rate. Is that true? No, Bridget, wrong. If it was a constant rate, what would it look like? Linear, a straight line, right? Greg says, wow, when T equals 50, the bank account's value will be 1,000. Well, is that true? How would we go about trying to figure that out? Put it in Desmos, or you could take 50 and plug it into this equation really quick. So 200 times 1.025 raised to the 50th power. What does that give me? Somebody. I'm not doing it. So if I have 1.025 raised to the 50th power, and then we multiply by 200. It's how much? 600. Okay. Is that $1,000? No, Gregory. Allison says based on the graph, the average rate of change for the interval. Hey, shh. Okay, the average rate of change for the interval from 30 to 40 is greater than the interval from 0 to 30. What is average rate of change? What's another word? Slope. Okay, so slope, we find slope by doing y2 minus y1 over x2 minus x1, right? Okay, I need to know first, what is the y value for when x is 40? Somebody tell me that. So if I took 40 and I plugged it into this equation, what would you get? 537. This graph is wonky then. Okay, so 537 here. This only changes like this much, right? Oh, JK. Thanks, Mom. Okay, so this only changes like this much, right? Over a 10 period. Over here, from 0 to 30, we go from 200 and we go up to like 400 and something, right? So, but that's over a period of 30, right? With me? So 200 divided by 30, how much does that give me? Over, yeah, well, 20 divided by 3. Huh? 0.670. It's 6.7. Okay. And then over here, if we go from 400 to like 537, that's like 137 divided by 10. So what is that going to be? That's going to be 13.7, right? Which one's bigger? This guy, right? Okay, is that what they said right here? Yes, Allison is correct. Really quick, what you're going to be asked with these questions is very similar to this. It's key features. You are asked about the y-intercepts. You are asked when you plug in a certain value, do you get this? You are asked about the average rate of change. Okay, so that's gonna happen. Dun, 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 dun. Okay, so we're gonna kind of move into more money problems, not like issues, but like problems. So really quick, you need to pay 8% tax on a car that costs $12,000. What will you end up paying in total? Take a moment, write these two questions down. I want you to answer these two questions. Okay, so when you go to the store and you buy like a Snickers bar. Yeah, same. Okay, when you buy a Snickers bar and the price tag says $1.99, how much do you spend? You spend more than that, right? Because tax, right? Okay, so we had something with $12,000, right? We're gonna spend $12,000 plus, how do we find 8% of 12,000? Multiply 0.08 times 12,000, right? Okay, so what does that give me? 96. Okay, so when we add 12,000 plus 96, we get 12,096. Ta-da! Now, ready for this? Burritos are on sale for 30% off. First of all, don't eat a burrito if it's 30% off. It's probably expiring. Don't do it. Okay, your favorite burrito normally costs $8.50. how much does it cost now? Okay, so first we've got to figure out how much is 30% of the original, right? So we're gonna say 0.3 times 850. And what does that give me? To what? 55. And then we're gonna say, we're gonna take this and subtract it from that 850. We're gonna say 850 minus the 30% off. So what is that gonna give me? $5.95. So your burrito went from 850 to 595. Don't. Doesn't necessarily don't. I'm gonna go back to this first one. Make sure make sure that you put 0.08 and then multiply it times 12,000. That's gonna give you 960. 960, not 96. That'll give you $12,960. A lot more. Okay. A marine biologist estimates that a structure of coral has a volume of 1,200. And that its volume doubles each year. Create a table to find the volume of the coral when it's 0, 1, and 5 for T. So at time equals 0, how big is this coral reef? Nope, 1,200, right? All right, now it's doubling each year. So after 1 year, how big is it? 2,400. When we multiply it again, we're gonna get 4,800. When we do it again, we're gonna get 9,600. When we multiply it again, we're gonna get what? And when we multiply it again, we're gonna get like 30. Okay. All right, so take a moment. Okay, so now consider when C equals -1 and -2. So remember how I was like, you really can't have negative time? Well, you can't have negative time, but that being said, we can talk about previous time a little bit, okay? Normally, it's kind of frowned upon. So if we wanted to find when C is -1, we would look at our table, and we're at 1,200 at 0. If we wanted to go back in time, what would we do? Divide by 2. That's going to give me 600. If we wanted to do it again, what would that be? 300. So C equals -1, that's going to be 600. When C equals -2, that's going to be 300. This is going off of the stuff that we learned yesterday. We're going to write the equation for that relationship. So what was our initial amount? How much did we start with? 1,200. And each year it did what? It doubled. That was our rate. And we're going to raise that to the T power, right? Okay. Now we want to find in a certain year the volume of the coral at 37.5 cubic centimeters. So we're not plugging in T for 37.5. We're plugging in V for 37.5. How would we go about solving this? Go ahead. Well, we've got this 2 raised to an exponent, right? So that's not going to work. But we could divide that 1,200 on both sides. Okay. What's another way, though, without having to really do much math? Not subtract, but we could plug it in Desmos. Let's try that really quick. Again, I don't want to have to do math. Nah. Okay, so when we go into Desmos, what we're gonna do is we're gonna plug in that right-hand side, and then I'm gonna set a line equal to 37.5. Okay. When we look at this, we're gonna look at where they intersect. And we can see that happens at x equals -5, right? Well, at t equals -5, our volume is gonna be 37.5. So what I did was I took my equation that I just found, put it in, and then created a line at y equals 37.5 and saw where they crossed over.